more about defining object-like macros, and what this shows is that we cannot redefine a macro, the value of a macro, unless we first undefine it. We cannot change line and file predefined macros directly, but we can use line. And if we do it like this, the preprocessor will think that the source file that it is translating or reading is called this, and it is at line 124. You may think that this is a bit weird to want to change the line and file number, but it's very useful if we use C as a, so to speak, portable machine code. C is often used to translate one source language into machine code, I mean into C, and then use a C compiler to produce the machine code. Okay, I don't know if anyone has done this for Scala. I don't think so, but this is just for illustration. Okay, this directive error, it causes the preprocessor to fail the compilation. And if translation comes into this, then it will fail. If standard C is defined, then this line is skipped, so the compilation will continue as if this does not exist. And if we can have several error directives, and it's implementation defined whether the preprocessor will stop at the first or continue, but anyway, I mean regardless of which, it is certain to exit with error. Okay, pragma is a way to give special information to the compiler, such as that the next loop should be executed in parallel. That can be done using something called OpenMP. And if you take multi-core programming, you will learn about that. And originally it was just the text here. But then it was realized that it would be nice if this would be macro replaced, so that we can use macro expansion as the parameter here, and then it will be somewhat more flexible. The stringizer operator is a hash and then followed by a parameter, and the effect of this is that, well, we can look at this x and str. If we give C there, it will produce a string with exactly the name of the parameter. I mean what it is here. Okay, if we instead want to have 12, I mean a string with 12, then we have to do this in 2 steps. So it's done like this, and this parameter b will be discovered when the preprocessor checks the definition of this, and it will see that this xstr is in fact the name of a macro. So what it does then is to replace this b, and here it is a C. So it expands C into 12, and then it gives 12 as the parameter to xstr. Okay, and then when it comes here, it will make a string with 12. Why do we want this? Well, it can be convenient to be able to write the name of a variable, for instance. Say we have a macro that should inform the programmer that some disaster has happened. So we can use it like this. And well, why would we want to have this? Well, say we have this variable and we set it to 2. And then we use this. This could be, for instance, in unexpected part of the program. So, for instance, in a default of a switch, if we didn't expect the default case to be taken. Okay, so then what we can get is the file, the line number, which function, and the string of the parameter, and then the value. Okay, so how does this work? Well, first we use fprintf to print the standard error. That's system.err in Java. Okay, and then we want the file, so we use this macro. And then we want the line, so we use this macro. And then we want this function name. There is a predefined character array called func, which contains the name of the function. This is not the macro. It's an array, and it's only produced if somebody uses it. So not every function wastes memory, but if it's used, then the compiler will produce it. Okay, so this is an array, and since it's not the macro, instead it's an array, then it uses small characters instead of macros, which use capitals. Okay, so now we want the identifier here. So we get the stringizer operator. I mean, we use the stringizer operator for this, and then we get out the x, and then we use just the expression. I mean, this the parameter here, and it will contain 2, and we print it, and then we exit 1. Exit 1, well, exit terminates the program, and exit 1 indicates an error, and exit 0 indicates success. There is another operator which is somewhat similar to this one, but not really. But it's another. If this one is rarely used, this one is even more rarely used. What it does is to concatenate, that is merge, 2 tokens. So if we define something called name, and we have an ID and type, and we can call it with x and int, then this will create a new token which looks and behaves as an identifier with these 2 pasted together. And why would we want to have that? Well, if we one example is if we implement a function that should have implementations for different types, but the code is really the same. I mean, it looks the same except the type. Then we need to have different names for these functions, and we can create them like this. This is not very frequently used, but sometimes it's used to create library functions. Okay, and we can just merge them as they are, and then b will be initialized to, well, b will be a, and a will be this, and that is 12, so b will be set to 12. Sometimes it's nice to have a variable number of arguments, and not only to printf, where we can have any number of arguments, but also to macros. And then we can use this. Oops. Here is an illustration. So if we have defined, well, we want to use this to print, debug prints. Okay, and then if we define this macro debug, then it will be defined to print. If debug is not defined, then it's defined to be a comment. That means absolutely nothing, of course. So how does it work? Well, we start with using 3 dots, and when we use the macro, if there would have been a parameter here, that would be matched to the first argument here, but there is none, so everything will be put into these 3 dots. And then when we want to get them, we use this. So this VRArgs contains all of this, which will be used to print the error message. This is very useful, since now we can have, we don't have to comment out and edit lots of lines more or less conveniently, but instead we can just change in one place and to get the print or no prints.